My sickness is finally starting to go away. So I'm starting to feel better, which is good. Oh, my local computer's down. 1 second, I'm gonna turn this thing on. All right, so today we're working on making our own segment anything model, and it's a little bit different. I say our own segment anything model. I'm going to try to use a lot of the training processes they use. I'm going to use a different architecture for the model. I think that I could be totally wrong about this, but from what I'm seeing, it feels like a lot of the architectural choices are less important than I guess, where you're getting your data from and kind of the process around how you're improving your data and training your model. It's more like the macro that seems a little more important than the micro being like the architecture or the transformer architecture. There are a few caveats there, like there does seem to be some evidence that the transformers, when they get really big and you have a ton of data, do a better job of improving than like a traditional convolutional net. And that could obviously be very significant in some ways. But I just feel like for my project, what I'm working on, um, I don't need to create life. I just need to um, repaint houses is my goal. So, and also the other reality is I can't have these massive transformer models anyway. So it's like, even if there's a lot of value there, then I'm working on the wrong thing basically. So I'm just going to try, what I'm doing today is I'm going to try to train my Unet, which is a CNN, in a similar-ish way as to how segment anything was trained. And then I'm going to, and this might go more into tomorrow and later next week. Um, I'm gonna try to basically fine tune, or not fine tune's the wrong word. I'm gonna create masks, and then I'm gonna find masks that aren't performing well and manually improve those and just iterate that process. The reality is that's what segment anything the team did. It's more like working with the data to get things really good than anything else, to be honest with you. They did use a big model architecture, but even the segment anything model architecture is like kind of basic bitch in a way. It's like they're not using any sort of um, different scales on different image scales on their um, segment anything. Like Swin uses different uh, basically it scales the image down in the transformer model, kind of like you do in a Unet model. The details there I'm not fully sure about, but I understand it uses different window sizes. So it basically is looking at the image in various scales. Um, so it's similar to a CNET in that way, and that I think becomes important mostly just for efficiency, uh, mostly just for efficiency reasons. Um, because you're going to get a lot more bang for your buck that way. But those transformers, they start to get pretty complex. I mean, it's not like crazy, I'm sure, but it's just a whole thing getting into. And there's also some nuances around training transformers that seem harder than just a traditional uh, CNNs or UNets. So, um, and honestly, the biggest I'd probably just use segment anything, but I can't get it to like when I just tried to train it to create a perfect rectangle, it won't do it. Like it create like the edges are rounded, and it just drives me crazy because like if I'm trying to mask parts of a house, like I need things to make straight lines and be rectangles, and my like a simple CNN Unet can do that. Um, if I like tweak the settings on the segment anything model, basically I have to just make it so big in order for it to get the edges right. It's an annoying thing. I don't know why it annoys me so much, but it's just the feeling of lack of control over something drives me nuts. And I can also just feel that like, okay, if this is a problem, there's going to be other problems too. Also, I have done masking with segment anything already. I've been working on this project for like a year, so I'm well aware of how good it of masks it will produce, and they're not good enough. Like, I don't know how else to phrase it. It's the funny thing about AI. It's like um, sometimes it just won't get the job done, and you're kind of just stuck. It's not like heuristics where it's like, all right, this isn't where it needs to be. I'll get it where it needs to be. Like if you're able to get the AI where it needs to be, congratulations, you know have just built a new the next biggest company in the world. So uh, it's a harder problem than people think. All right, I'm just gonna get after it. I'm mostly just gonna be programming like a ton today, so I probably won't be talking that much. $11,000. So Facebook launched a data set for segmentation. And that's what I'm training on. So we'll see how often this is occurring, but I just don't want to bother with handling this. So it'll just return nothing. If that happens rare enough, it should be fine. I just want to see how often this is happening. Oh, wait a second. Oh, I'm sure it's not. Mm, it's happening pretty often. You know what? It should be all right. I'll fix this later. half. The same thing. Half, half. So I'm just going to concatenate this, the embedding. It has the same spatial dimensions. They'll both be like, I don't know, 1/4 of whatever the input size was spatially. Um, and then it'll have 32 channel dimensions. I did mean prime to embed. Fixing some syntax stuff. So I have 11,000 samples. I'll get more probably, but you can get a good feel with 11,000 of things, how things are working. It's been a little while to train. Even before I create a check accuracy function, I usually just like get a feel to make sure. Oh, and we're like in the ballpark of being right. So we should see some. And the other thing I want to do is make sure my image and my mask are in the right format. Jeez Louise, that's been a lot. Uh, okay, that looks right. Yeah, okay. Wow. Well, 1 second. I want to see some ones here. If I see some ones, I'll be okay. I should see some zeros there, to be honest. I probably should make my generator model smaller too, just so it runs a little bit faster. But we'll see. Okay. So just assume that everything works exactly how I want it to here. What do I do next? You know what I want to do is I want to get a feel for what it's creating. So I'll create a check accuracy function. And I happen to have one that I like pretty good in here. It's big. It's big. But we gotta do it. Okay. I'm not. Python's a little bit. The thing that annoys me most about Python is I'm probably an idiot, to be honest with you. I'm sure there's a way to get around this. I hate having to put things like this check accuracy above. I guess I could put it all, call it a main function. Do this. Well, don't need any of that. Don't need any of that. Okay, so image original, that's fine. Mass prediction, mass pill. That should get us there. Ah, I'm confused. Here's your problem. Mm, 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 mm. Basically seeing if it's working at all. Doesn't seem great. Personally, I feel like it should definitely be working. Let's do 1,000 images. It should definitely have some sense that's like, okay. Oh, so here's what I'm doing. Let me explain. What we have is I'm using the segment anything data set, and this is what it looks like. It's simply an image, and well, how they put all these masks on here is a little bit complicated, but let's basically just say they had somebody come in and put masks on every object or everything that they saw in the picture, but they didn't. The masks don't have labels, so this mask isn't being like labeled shirt or anything. It's just a mask. So they're not annotate. They're not labeled in any ways. Like this could be a hand, but it's not. There's a face. But so what I'm doing is I have this data. I have a bunch of images with the masks, and I select an image at random. I'm currently I just have 10,000 of these. There's a lot more. There's like 10 million. I select an image at random, and then I select a mask at random. For example, I might select this mask, which is just this girl's face, and then I select a random point in the mask, and I give the model the point and the image, and it has to predict this mask. Um, so it should, in my opinion, it should start kind of working a little bit. I mean, you can see this loss is for the most part going down. I should probably get so it's not random on the test. Well, it's still not very good. I mean, how low it has to go. Seems bad to me. Let me just check my model and make sure that. So this is my Unet model. Pretty simple. It has a convolution, actually a double convolution. I just here's double con. Basically, you can see in my forward method, I just will go down. I encode it. This max pooling will decrease it halves the image size. So if it's 256, it'll go to 128 by 128. Halves the image size. Keeps having. And then this upsamples, it makes it bigger again. So it goes back. And then I also have skip connections. So at every point you're passing, you're concatenating. Anyways, Google skip connections. Uh, and then I'm passing the point here in the bottleneck. Or concatenating in the bottleneck. It's possible that the way I'm doing this is not going to work. I think it should. But it does seem to be just producing all black images. Let me see let me just make sure. My loss is definitely going down. It's weird to me that I'm not seeing masks yet. Let me just make sure that I'm saving this right. So mass prediction. Yeah. I feel like it should be working. I mean, my loss is definitely going down. I need to make this so it's always the same. Just kind of hard to do. I'm still not seeing it create any masks. I wonder if the way that I'm passing the prompt is not good. So let me try. Let me just do something a little different. I'm going to, instead of trying to encode that, I'm just going to pass it as another channel to the whole model to see if it makes it easier for the model to learn. It might just be like a little too much. So basically, I'm just going to take out this prompt embed. We just are not going to do that. And what we'll do instead is we'll just concatenate it. We can just concatenate this prompt, which is just an image with one pixel to the beginning. uh, let's do that. So it'll be 4 channels image instead of 3 now. All right, let's try this again, see if that works better. I'm super annoyed that this doesn't work right out of the box, to be honest. Should work. What the heck? It's a weird shaped image. So they have a lot of different shaped images, which is good to know. I'm just resizing mine to a square, all of them to a square. So this might be working worse. Love that loss. What does this look like? Going down. At least learning how to generate a block. a black image. I'm getting over a cold. All right, while this is doing this, I'm going to think. All right, so if this works really well, which it should, what do we do next? Hmm. Possible that this MAE boss is having trouble. Hmm. Oh, you know what else I need to do? Is on my generator, I want to add another head, more head. I always want to give my generator more head because the more head, the better. So I want to add a prediction, like a predictor that predicts the masses. What is it called? Mass decoder. IOU prediction. I want an IOU prediction head. That's what I want. Okay. I'm trying to understand is the shape of these IOU predictions. One idea. I've worked with Sam. Run out of memory. Don't run out of memory. Don't run out of memory. It's taking so long. Don't run out of memory. What the hell? Okay, so this shape is predicting. Jeez Louise. I'm not sure the shape because I'm printing other things. That's the image embedding image. So it's one by one. What's ahead? Ahead is like ahead on machine learning model. It's a little bit confusing, but it's basically like a layer that you put on the end of the model. I was a little confused because you'd think it would be at the beginning, but it's basically another layer that you add to the end of a model that does some additional processing on the output and can do something else potentially. So that's what I'm adding is ahead. So this IOU prediction is, I'll show you an example actually. So this, um, so right now my model, this generator here, Tays generator, we'll close this up, is only producing, it just has one output. So I'm gonna make it have two outputs from the other head. And what I'm gonna do is basically it'll be a classifier, a simple MLP classifier. Well, it'll be kind of an MLP classifier, but I'll take the bottleneck data and I'll make it predict how good the masks is that it thinks it's generating. It's a little bit confusing, but all right. And also this doesn't seem to be working, so I'm gonna stop it. And I think I'm gonna try um, mean absolute error, like isn't always the best. Let me try BCE. It's just a different type of loss. Uh, a lot of the time, for some reason, the MAE loss just doesn't work. So we'll try the BCE and see if this converges. I'll be mad if the MAE is not working, to be honest, because it should work. When it's not working, it's like generally not good. What the heck? Where's my Criterion BCE, Criterion BCE. I'll crank that back up. Um, but if it is the, I'll figure that out in a second. Also, adding this IOU head could maybe help. Uh, and at least get uh, debating how to do this. I need some flexibility. Yeah. Oops. No, I get it directly from the bottleneck though. This would just be a two-layer MLP. Um, so what I'm gonna do. I'm gonna make it. My prompt embed. IOU head. Here's my IOU head. It's gonna be a nonlinear. We're going to I don't know if we need normalization. Add a ReLU. And we're gonna have three of these. Almost never need more. If you need more than three in an MLP, I don't know. It's a problem. And this will be 256. Actually, I'm not sure how many in features we're gonna have. I got to see how this shape is. Hey, bitch. Use that average pool. Yeah, that's right. It's Princhul. Yeah. So each head, oftentimes, yeah, you'll, well, uh, yeah, oftentimes you'll like train different, you'll train a head on a different evaluation metric. Yeah. So I'm going to use this IOU head and train it on a different loss, which is basically this loss that I'm trying to get from ChatGPT. I think you basically will take the segmentation mask and compare it with the ground truth and see how well it overlaps. And if it overlaps really well, then the IOU head score will be high. And if it is uh, not uh, overlap doesn't overlap well, then it'll be low. Um, and we can use that to basically be like, all right, we're going to predict a mask using MAE, and then we'll also be like, then how good do we think the mask is? And there's all sorts of helpful things that we can do once we have that metric because it's like a confidence score basically. Uh, the segment anything, they like really abuse that, and yeah, so I'll use the IOU heads, and one of the reasons it's important to me is because I want to be like, I'll train my model, and if it has a really high confidence that the mask is good, I'll be like, that's fine, that's great. But and then for the masks that are bad, I'll go in and I'll get those, and then I'll like relabel them myself. So when it has problems creating masks, I'll use those to create like I'll manually label those. What's that? One by one. Print shop. What do you? Uh, is it? Yeah, look, print shul. What do you do? Are you do machine learning for a living, or what do you do? This is 1024. Data science is nice. Yeah, yeah, that's basically what you want to be in these days. Data science, in my opinion, is like just a person who's actually knows machine learning, but isn't like trying to raise money, so they just use the word data scientist. Okay, so what was it? 1024. Uh, are you using a lot of like machine learning type stuff? Uh, or not so much in your data science? I mean, I'm sure it's like by machine learning, I mean like MLP style stuff. Still doesn't seem to be working. ABC. Let's see if ChatGPT gives me. Okay, here's the IO. I wonder if PyTorch has a built-in. Yeah, I'll just use this. All right, here's the IOU loss that ChatGPT created. All right, so we already have predict. It's already sick. We're already applying sigmoid. Okay. I don't really love that, but okay. Intersection and union. That's what IOU stands for. Safe division. All right, whatever. So don't know. Oh, life. Life is being created. Learning. Learning. See, it's creating a little dot now. Not very fancy, not very sophisticated, but what do you expect? This could be one for a while. I did like to see that life being created. I'll be back. I'm gonna get some more coffee. Keep thinking about what to do here. It's way better when I'm gone. Alright, something's wrong with my IOU score. I'm all confused by how this is always won. Like, you should know that you suck, right? Uh, yeah, let's see. The thing is, we're actually trying to predict the IOU score. We're not trying to decrease the IOU score. So it's a little bit different. It's an IOU prediction hit, right? Not just trying to decrease it. We're trying to predict it. So we have the IOU loss. Let's just try to predict the IOU. So here's our mean. That would be the loss, but we don't want it to be a loss. We want it to be actually we could do IOU loss. I should call this IOU prediction loss. And then our difference is we'll use mean square. Is our prediction. And all right, so it should be pretty good at figuring this out. Prediction and our actual. So it should know that it sucks. Little self-reflection. You want to know when you're bad at something. Should definitely have a sense that it's bad. I don't know if they have their training. I don't think they release any training code. It's probably wise. I don't know why Facebook does any of this, to be honest with you. I don't know why they bother releasing anything publicly. I wouldn't. Well, maybe I would. I wouldn't if I was that big, to be honest with you. Seems like a bad idea. Facebook definitely seems to be doing this like the most in computer vision. But no other company really seems to be like releasing a lot of open source stuff besides Facebook. I'm trying to predict the IOU, so I know how good the the masks that I predict are. Um, that way, like if it's predicting good masks um, on a part of the image, I can just leave them alone. But if it's predicting bad masks, I'll go in and I'll manually edit the mask to be better. So it's that was the process that Facebook used for segment anything, and that's the process I'm going to use for my project too, if that makes sense. It's like I think it's important to be able to know how how confident your model is in its predictions because you can end up doing a lot of stuff with it. Um, you know what else I think I'm going to do is I'm going to make this smaller because it's just too big. For sanity's sake, here, do this. It should. Wait, is that right? Here, no, watch. 4, 16, right? 64 times 16 is 1024. That's right, right? Uh, right. That's right. Right. Yeah, that's right. Base size times 8. Base size times 4, right? Yeah, that's it. What's 4 times 64? It's 256, right? Yeah. Whoops. 64 times 4 is, yeah. What's 64 times 2? Times 2, yeah. We have base size. Oh boy. All right. What was that? Times 16, right? Now I'll have a nice flexible Unet. People like flexible new guys. How we Doppler asks, I'm confused on how will it predict IUU on unseen data? That's a good. So I'm this is what I'm training on is the segment anything data set. So I'll briefly describe how it's training. So like I have an image and then I have masks on the image. This is a little bit weird because people just put mask on an image and didn't label it. But anyway, so let's say this is a mask. It's basically this dude's shirt. What I'm doing is in the data set, I return an image and I just randomly select any mask. This each image might have hundreds of masks on it, maybe like 50 or so. But I'll just randomly select a mask and then I randomly select a point in the mask. And then, so I'm giving the model the picture and that point, and it's trying to predict this mask. And the idea behind it is the model should get good at, so if you select a point anywhere in an image, it should get good at being like, okay, that's a shirt. It'll mask the shirt. Um, and so it basically, yeah, that's the idea. And so with the IOU head, you have a ground truth mask, which is this guy's shirt, for example. So that's the ground truth mask. And then my model predicts a mask, and then I get the what is it, intersection over union, the difference of my model's mask prediction and the actual mass prediction. So I get that. That is a real value. But uh, I'm not training the loss to decrease the intersection over union. I'm training it to actually get good at figuring out uh, how good the IOU score is going to be. Bottom line is it acts as like a confidence score type deal. I'm copying what the Facebook segment anything did. This is not my idea. I would not have thought of it. I don't even know what IOU is. But I mean, I may have thought of it. Like, it's not too crazy. Basically, you want to be able to get some sort of confidence score of how confident you are that your mask is good. There's other ways to do that too. Okay, that'll stay the same. Base size times 16. Base size times 8. Base. All right. Hopefully that'll work. I actually saw. If it trains for a little bit, I see it to start to work, but I'm just going to try. Make sure my changing the base size worked. What I'm going to do is make this model smaller. What is this? I think I wasn't getting this before. Oh, oh. What's up with my? This is not right. See if ChatGPT can fix this. Uh, per, should be per image mask in the batch. Yeah, your score's not right. ChatGPT does a lot of like rambling. I'm not sure. Is it changing anything? That doesn't. It does seem better. No. Oh, does why does IOU have a shape of 128 there? Does anyone know? Intersection divided by I need to take the 128's my image. Right. Not crazy. Dimension 1, 2. 1, 2. It doesn't make sense that I'm using 1, 2. I think I need to. Yeah, I think it needs to be maybe 2, 3. Let me see now. Squeeze the channel dimensions. Okay. um, this is most of Python is just reformatting tensors. Is it unsqueeze 0? Unsqueeze 0 wouldn't that add up to the beginning? That adds a unsqueeze 1. I lost my PRs without it, but all right, and then just want to see how much of the GPU we're using. Not that much. So let's ramp this up. See if we can go to 64 on the batch size without breaking. Want a big batch size. Nice big batch size. Oh, I'm still not using that much. Oh, that's not good. What the heck? Why is that GPU usage so low? Should be like 100%. One second. Just gonna make sure it's not messing up totally. Whoa. I wonder if it's because the data loader is being slow. But it is. I'm gonna put I'm gonna load the all this data in the init. I don't even know how to loop through things in Python. This is a little bit embarrassing. It's like for uh, image in self images maybe. I'm embarrassed. Hey Doppler, that was my that's kind of my understanding of segment anything. I think, yeah, but I don't think segment anything. They didn't launch. I don't think Facebook launched anything like publicly where you can correct the predictions. Um, in their paper, I think the way they trained it was they had like a basically like a web tool where they would be like, all right, if the prediction is bad, they like hired all these people. The trainers would like go in and find the bad predictions and fix those. But as far as I know, there's not like a public tool that does that. So one of the things I'm going to do is build that. I'm just going to whip up that tool, maybe today, maybe tomorrow. But basically, it'll just be like a simple little web interface where it'll draw the mask, and then you can like basically erase part of the mask or add to it, um, so you can fix the prediction. Uh, yeah, I actually had a hard time understanding the. I was reading through that segment anything paper yesterday. I had a little bit of a hard time understanding it exactly. But to me, it does seem important, like that continuous improvement. That idea, I think, is what works. And so, like a in building like a the process out for continuous improvement is what I'm working on. I think that's the most important thing. I'm realizing like the model architecture and stuff is, I think, less important because, uh, like, I'm not even using a transformer model here. I'm just using I might change it to a transformer model if this Unet doesn't work, but all right, so this should speed up my training quite a bit. So I'm just gonna load it all up into memory. And then we'll loop. Yeah, because this is way too slow. Yeah, that's super slow. That was my problem. I'm just gonna do 1,000 for now. I just think parsing these annotation files takes forever. Probably what I'll do is I'll put this synchronized transform in to the get item, but that's why it was taking so long to train, because it takes like 30 seconds to do 1,000. So I'll load that all into memory. And then be in memory. And then when we do, yeah, so now our GPU is cranking. Kind of. Yeah, I mean it's going. Yeah, so we're going a lot faster. Honestly, that been part of the reason. So this IOU prediction loss is super low, which makes sense right now, anyways, because it know that it it knows that it sucks. It basically knows that it's gonna predict it wrong every time right now. But our BCE loss is going down. It'll continue to go down, and I bet uh, I bet we'll start seeing masks being produced. So, all right, I'm gonna go for a run. So what I'm gonna do here is I'm gonna I'm gonna train this for a bit, go for a run, and come back and see what sort of results we're getting. And I'll be back on in about an hour. So, all right, I'll see you guys later.